Antenna directivity helps send a signal to a specific place. Remember that when elements are added to a dipole antenna, a Yagi-Uda antenna is created, and the radiation pattern changes from omnidirectional with the signal spread out equally in every direction to a pointed beam. This means the Yagi has a strong, powerful signal, but only in one direction. The extra elements in the Yagi-Uda antenna are passive because they aren't powered with a signal like the driven element. Passive elements mean that the Yagi-Uda antenna only broadcasts in one direction. In order to change which direction the antenna is broadcasting, the whole antenna must be rotated. However, if the passive elements are replaced by driven elements, the antenna has the capability to steer electronically rather than mechanically. This electronic steering is called beamforming. To see how this works, let's start by looking at how water drops create waves. A single drop of water creates a wave that spreads equally in all directions. This is the same principle as a single dipole antenna with an omnidirectional radiation pattern. However, if we use 2 drops of water, the waves interfere with each other and create calm places where a wave crest and trough cancel out, shown by these 2 dark spots. There is a large wave in this central area where 2 crests combine, and several smaller waves off to the side here where the crests only partially combine. This is similar to a Yagi-Uda antenna, with 1 large lobe, nulls, and smaller side lobes. As more drops of water are combined, the wave patterns become more complicated. Using 5 drops of water, there are several lobes and nulls spreading out equally. This is similar to the radiation pattern created by a uniform linear array, with 5 antenna elements in a row. However, this isn't an optimal pattern for communicating with antennas, since it isn't omnidirectional or highly directional. By staggering the timing of the falling water drops, the main lobe begins to shift. If different sized drops of water are used, the side lobes can be eliminated. This is an example of electronic beam steering with a uniform linear array. By changing the timing and the size of a signal's amplitude, it is possible to change the signal's direction without physically moving the antenna. Beamforming allows antenna arrays to be used for applications such as Wi-Fi, cellular, and radar transmissions, where making a direct connection with a moving target is important. The more elements an array has, the more focused the radiation pattern becomes, and the more directions a beam can be steered. So modern antennas use beamforming techniques with arrays that contain as few as 3 antennas, like this Wi-Fi router, to over 5,000 individual antennas, like the PAVE-PAWS early warning radar system. Typical antenna array element arrangements include rectangular arrays and elliptical antenna arrays. RF technology is a complex, dynamic, and advancing area. While dipoles and phased arrays are examples of fundamental structures in wireless communication, new technology like Wi-Fi and the 5G network continues to impact our lives in unprecedented ways. The future will largely be shaped by how we understand RF technology and how we use it to change the world.